Now question 6 goes as when a block of mass 12 kg is placed on a rough plane inclined at an angle alpha to the horizontal, where alpha is tan inverse of 0.5. Force of x Newton is applied to the block directly up the plane. The coefficient of friction between the block and the plane is mu. It is given that mu is 0.15 and x equals to 20. Find the time that it takes for the block to move 2 meters down the plane from rest. So now they are talking about the journey in which A will move, the block will move downwards. Okay, when it will move downward, if the weight is more than the component of weight is more than the x, then it will move downwards. So x here is 20. It will move down, so there will be mu r. In the backwards direction, there now resolve the weight. This is how we resolve it. First is perpendicular to the plane. The first line we draw is perpendicular to the plane, and then we draw parallel to the plane. So this is like this. This is 12g. This is your theta, so 12g cos theta, 12g sin theta. Okay, alpha. When this is your alpha. Okay, and yeah, these are all forces that are acting. Now when they say it moves, when the body moves, that means you are supposed to apply forward minus backward equals to ma. That means the forward forces minus the backward forces should be equals to ma. Also, there is one more thing. Always in the point of contact there is normal reaction force. Okay, so we will be writing using when it is movement, when there is acceleration, so we'll be using forward minus backward equals ma. What is the direction of motion? Downwards. So forward is all the forces along that direction, so that is 12g sin alpha. So 12g sin alpha minus backward is the mu r, the frictional force, and the x Newton, minus frictional force and minus x equals to ma. Mass is said to be 12 kg with acceleration a. Okay. Now let's substitute some of the things. 12g sine, what is alpha? Alpha is tan inverse of 0.5. Keep it the same way to have more accuracy in the question. And minus f is mu r, mu times r, minus x is 20 equals to 12a. What is r? How do we find r? This r is equals to the downward force, up equals to down will give you the r. So r is equals to 12g cos alpha. Upward forces equals to downward forces, so r equals to cos alpha. So r will be equals to 12g cos tan inverse of 0.5. So this will give you r. Okay, just substitute it this way in the without solving it, just substitute it and then find it directly in the formula. So 12g sine of tan inverse of 0.5 minus, what is mu? 0.15 times r So from solving it all in a calculator will give you acceleration, and that you will get it to be 1.469. Wait, let me see what it gives. 1.4638. Okay, this is your acceleration. Now we need to find actually the time. So for the time, using s equals to ut plus half at square, s is 2 meters, because how much time it takes to move 2 meters. So 2 meters equals to initial speed to be 0, because is it given here? How is it given? From rest. So this is initial speed to be 0. Okay, so plus half, acceleration is 1.4638 t square. So from here, when you solve it out, you will get time to be 1.653. Okay, this is your time. Now let's move on to part B. Part B says that it is given that mu is not equals to 0.15, and that when x equals to 10, the block is on the point of moving down the plane. On the point of moving down the plane means it is limiting equilibrium, about to move, not moving, not equilibrium, limiting equilibrium, about to move. Find the value of mu and the value of x for which the block is on the point of moving up the plane. So for this reason, let's take this diagram, or actually for it I need this the same, because now again the body is about to move down, so it means we will be taking the same the same mu r, the directions will be the same because the body is about to move down. So only there will be no acceleration here. Okay, so when there is a limiting equilibrium, so we apply the rules of the same equilibrium, that we apply up equals down and right equals left. Rightward forces equals to left forces. Also x is not equals to 20 now, x is equals to 10. So up equals to down gives you r equals to 12 g cos alpha, the same. Tan inverse of 0.5 and right equals to left will give you uh, both forces are on the right side, like none is in the yeah, there is. Left force is 12g sine alpha and the right is mu r plus x. So let's write that 12g sine alpha mu r. So 12g sine of tan inverse of 0.5 equals x plus mu r. What is x? 10 plus mu is now different, so we will not substitute the value. So 12g cos of tan inverse of 0.5. Okay, solving this all will give you mu to be equals to mu equals to 0.4068. Now this was just to get the value of mu. Actually we need the value of mu and x for which the block is on the point of moving up. So mu will be the same for the limiting equilibrium even if it is about to move up or about to move down. So we're using the same to find the value of x if it is about to move up, sorry. So now change a few things. About to move up, so now the direction would be this. Now mu r will be, if it is about to move up, so the frictional force will be downwards. X is no longer to be 10. The rest of the resolved forces are as it is. Now we are again going to apply the right equals to left. Up equals to down is already there. R we found to be equals to 12g cos alpha, so it doesn't change. Now we apply right equals to left. So the rightward forces are now only x and left is mu r plus 12g sine alpha. Yes, 12g sine alpha plus mu r. So now substituting the values, it will give you mu is to be 0.4068. What is r? Your r is the same. Sorry, it is taking a little while now. The document is heavy now. Okay. Fine, so let's substitute that. Plus 12g sine tan inverse of 0.5. Okay, so this is it, or so from here you get x to be equals to 97.327. Okay, this is your x in newtons. So what we have done in part A, the body is accelerating downwards, so we applied forward minus backward equals to ma to find out acceleration, and actually we needed time, so then we substituted in the equation of motion to find time. Then secondly, in the part B, they asked you to find mu and x. They have given you two cases, first about to move down and then about to move up, so we used each case. It is very important to please make the diagram again. Don't try to do all the workings and all the components and all the directions on the same diagram. This will make it confusing, so do the cases separately and then it will be very much easier for you. So that's all about question 6.